In this video, we will explain the notion of general solution. We have noticed that given a differential equation like dy dt equal, let's say, 2t, we have many solutions. An example is y1 equal t squared. This satisfies the differential equation, or y2 equal t squared plus 5. But then we would like to collect all of the solutions, and when we have all the solutions, we say that we have a general solution. I will be more specific about this later. Another example would be like if we have dy dt equal y. In this case, one solution is y1 equals 0 works, right? The derivative is 0, y of 1 equals 0. Y2 of t equal to e to the t also works, right? When you have the derivative of that function is equal to the function, and also like y3 equal 4 times e to the t also work. The derivative of this function is the same. Now let's do another example. Dy dt equal negative 3y. We have again y1 equals 0 works, right? Now y2 equal to, let's say, e to the negative 3t works. When I do the derivative, then I have a negative 3 times e to the negative 3t, and we get that it works. And another one that works is like 7 times e to the negative 3t. Maybe more examples. Let's do another example. Let's consider the second derivative of y plus y equals 0. We have that y1 equal to cosine of t is a solution. Notice that the first derivative is negative sine of t, and the second derivative is negative cosine of t. And when you do negative cosine of t plus cosine of t, it's 0. Another solution is sine of t, and maybe a third solution is like 5 cosine of t minus 7 sine of t. We can check that this solution works. But in this case, we're going to see that a possible general solution is something like t squared plus a constant, right? Then, and it doesn't matter what constant we pick, this is going to be a solution. Also, we can write a general solution for this differential equation as t squared minus 3c. We notice that they may look different, but they accomplish the same task of any solution that you get for this. For any solution that you get for this differential equation, you can find a constant such that this is a solution. In this case, the solution is going to look like c1 e to the t. In this case, the general solution is going to look like c1 e to the negative 3t for this differential equation. And for this differential equation, a possible general solution is going to look like c1 cosine of t plus c2 sine of t. But let's be more specific about what is the general solution of a differential equation. Let's write a definition. We say that an expression that depends on t and some constant c1 up to cn is a general solution of an ordinary differential equation if for every solution, let's say y tilde of the ODE, there exists unique values for C1 up to Cn such that this solution is equal to the y, this y of t with these particular choices of that. Then this is the notion of a differential equation, of a general solution. Let's do this example. Dy dt equal 2t, and I claim that y equal to t squared minus 2c is a general solution. It's a general solution. And then, for example, if I think about this particular solution, y tilde equals t squared minus 6, then is it true that there exists a unique value of c that makes these two functions equal? Yes, you can see that the only we can pick c equal to 3. If I pick c equal to 3, then this solution becomes the one that you already have. Then it doesn't matter what particular solution I take for this, I can find a constant such that these two are equal. That's the notion of a general solution. And maybe the most important theorem that I'm going to refer to this video, not because it's difficult, but because it is going to be used a lot, is the one that it says that theorem. I'm going to write a big theorem. It says that the general solution, or maybe I should say a general solution. A general solution for this differential equation is y equal to c e to the kt. Let's do an example. Let's consider the differential equation dy dt equal negative 2y. Then according to this theorem, the k is equal to negative 2. Then y equal to c e to the negative 2t is a general solution. For example, I know that y tilde equals 0 is a solution of this differential equation. Can I find a c such that these two are the same? Yes, I can make this equal to this if I make c equal to 0. Or for example, if I know that e to the negative 2t is a solution of this, can I find a c such that these two are the same? Yes, if I make c equal to 1. Then that's the idea of a general solution. I want to emphasize that I'm calling it a general solution because if you think about this differential equation and somebody claims that y equal to 3c e to the negative 2t is a general solution, e to the negative 2t is a general solution, that person is correct, because for every solution that you can think for this differential equation, you can find a c such that these two are the same. For example, for this solution, what would be the c for this general solution that make these two the same? I can pick c equal to 1/3. Just an observation. Notice that if I claim that y equal to c squared e to the negative 2t is a general solution for this differential equation, is that true or not? And in this case, this is not going to work. It's not going to work for two reasons. One, because if I pick this solution, y equal negative 3 e to the negative 2t, we can check that this function is a solution of this differential equation, but I cannot find a c such that these two are the same. And the other condition is, even if I claim that y tilde equal to 9 e to the negative 2t. For this solution, I can find two values of c equal 3 and c equal negative 3. Notice that one of the conditions is that for every solution there is a unique choice of the c that makes these two functions the same. Then for that reason, this is not a general solution, but this is a general solution, and this is a general solution. And what I will be using a lot is that if you have this differential equation like this, then this is a general solution. I think this is it for this video.